So now, after a couple of outings with concepts related to parabola, we are almost geared to solve problems. So the first sheet, titled Parabola Tune-Up, would get us familiar with some very basic applications in problem solving. Let's get past these and get a first-hand feel for problem solving in parabola, right? I hope you would have attempted some problems by this time and successfully at that, right? So sheet titled Parabola Tune-Up. So the first problem of the sheet is about a parabola y squared equal to 4ax and another parabola x squared equal to 4ay. And we are seeking to find common tangents to the two parabolas. We seek to find common tangents to the two parabolas, right? That's the objective. Now, which means a tangent to this parabola becoming also a tangent to this parabola. We are seeking such a tangent to the first parabola, right? Now, any tangent to this parabola would necessarily be of the form y equal to mx plus a by m. Any tangent to this parabola must be of the form y equal to mx plus a by m. Now, for some value of m, this will also become a tangent to this parabola. We are seeking such an m. We are seeking such an m for which this, which is a tangent to this, will also become a tangent to this. Now, if this is a tangent to this parabola, then the 2 points of intersection of this parabola and this line, if this line is a tangent to this parabola, then the 2 points of intersection between this parabola and this line must be coincident. Yes or no? Right? Which means now if I have to solve for between 1 and 2, then the roots, the two values of x and the two values of y obtained out of solving this must be coincident or equal to produce tangency, right? So now what I do is solve 1 and 2, x squared equal to 4a, y I can write as mx plus a by m. Clear? Now, this gives me a quadratic in x. The x coordinates of the 2 points of intersection between the line and this parabola, that is what I get when I solve this, right? So, x squared minus 4am into x minus 4a squared by m equal to 0 is a quadratic in x, giving me the x coordinates of the 2 points of intersection, right? And for tangency, the two values of x obtained from this must be equal. This quadratic must have equal roots, which will happen if discriminant is equal to 0, right? So discriminant must be equal to 0, which means 4am whole squared b squared minus 4ac must be equal to 0, right? Which gives me m squared plus 1 by m equal to 0, which in turn produces m cube plus 1 equal to 0, which has only one real root, which is m equal to minus 1, which has only one real root, which is m equal to minus 1. Right? So the common tangent will have slope m equal to minus 1. So put m equal to minus 1, this will become a common tangent between this parabola and this parabola. So m equal to minus 1 will give me y equal to minus x minus a by m, minus a, right? Which will give me x plus y plus a equal to 0. That's the common tangent between the two parabolas. That's the common tangent between the two parabolas. How about it? Right? Okay. Let's look at the next one. Can I wipe this off? There is a moving point A, a variable point A, given by x equal to -4, y equal to k. K is a parameter which will cause this point to be moving. And there is a parabola y squared equal to 16x. So this parabola is y squared equal to 16x. In this case, A is 4, right? Vertex is 0, 0. Focus is 4, 0. Directrix is x equal to -4. I hope all of you realize this. Right? The directrix of this parabola is x equal to -4. Now, -4 comma k therefore must be a point on the directrix. -4 comma k must therefore be a point on the directrix. Now from this point, tangents are drawn to the parabola. Tangents are drawn to the parabola. This is one tangent. This is another tangent. The two tangents then must be such that the chord of contact must be the focal chord, a property that we read, right? PQ then must be a focal chord. PQ then must be a focal chord. For any value of k, this PQ will be a focal chord. If I select different k's, I'll get different PQs, different focal chords out of this. That's the only difference, right? Now, each of these focal chords then will have their midpoints m, h, comma, k. M is the midpoint of this focal chord. PQ, M is the midpoint of this focal chord. PQ, right? If a circle is drawn with PQ the diameter, right, then M will be the center of that circle. M will be the center of the circle whose diameter is PQ, and we are seeking the locus of M. That means what are we trying to do? Connect the x coordinate h with the y coordinate k of the variable PQ, where hk is the midpoint from instant to instant of the variable called PQ, where PQ at all times will be a focal chord. Yes or no? Right? Now, if PQ is a focal chord, M, the midpoint of PQ, will be the center of the circle with the diameter PQ. If P is T equal to T1, that is has coordinates a T1 squared comma 2a T1. Q has coordinates a T2 squared 2a T2. That means T1 and T2 are P and Q, the endpoints of a focal chord. Then do you realize if M is the midpoint, then 2h must be a into T1 squared plus T2 squared? Right? H must be x of P plus x of Q by 2, right? Similarly, 2k must be 2a into T1 plus T2. Right? And to guarantee that this is going to be a focal chord, T1 into T2 must be -1. For this to be a focal chord, T1 into T2 must be -1. Yes or no? Now, to find the locus of M, what is it that we are trying to do? See, T1 and T2 are parameters. Yes or no? I want to connect the x coordinate of the midpoint H with its y coordinate K by eliminating all parameters prevalent in the scene. That's what that means. Using these three, I want to eliminate T1 and T2 and connect H and K, and then go ahead and generalize, replace H by X and K by Y. That's going to give me the locus of M. That's the whole idea, right? So the geometry over, the algebra begins, right? The algebra is very straightforward. Can I remove the clutter from here? See, if I square this, I get 4k squared, or rather, why do I need this 2? K squared is a squared into t1 squared plus t2 squared plus twice t1 t2, right? When I square this, and t1 squared plus t2 squared I can write as 2h by a, and t1 t2 I can write as minus 1. Yes or no? Minus 2, sorry, beg your pardon, minus 2, right? And k squared then is a into 2a into h minus a, right? Generalize this, replacing k by y, h by x, I get the locus of the center of the circle whose diameter is PQ. And what is this? It's another parabola. Do you realize that? It's a parabola whose axis of symmetry is x-axis, y squared equal to 0, whose vertex is a comma 0, and so on and so forth. Whose latest rectum is 2a. Clear? So option D. Option D then becomes appropriate. Sounds good? Can I wipe this off? Now, circle drawn having its diameter equal to focal distance of any point on the parabola. What is given is this parabola. X squared minus 4x plus 6y plus 10 equal to 0 is a parabola. Y, a quadratic in x, will be a parabola whose axis is parallel to the y-axis, right? Let's figure out this parabola. Now, in this parabola, whatever be it, this is the parabola. Y equal to a quadratic in x, its axis will be parallel to the y-axis. This is the vertex. The tangent at the vertex will be parallel to the x-axis, right? Now, for any point P, if S is the focus and a circle is drawn with SP the diameter, then do you realize it will touch the tangent at the vertex? If a circle is drawn with SP the diameter, with a focal radius as the diameter, it will touch the tangent at the vertex. Did I tell you? Right? So all that you need to find is, in this equation of the parabola, find the equation of the tangent at the vertex. Then any focal radius, the focal distance, circle drawn with focal distance as the diameter will touch the tangent at the vertex. Right? Okay, good. So we are all there now. This I can write as x minus 2 whole squared plus 6 into y plus 1 equal to 0. Isn't it? So x minus 2 whole squared is minus 6 into y plus 1. If you put the linear term equal to 0, you get the equation of the tangent at the vertex. Right? So tangent at the vertex is y plus 1 equal to 0. That is y equal to minus 1 is the tangent at the vertex. Yes or no? Bless you. So which means if a circle is drawn with SP the diameter, it will touch the tangent at the vertex. Clear? Y equal to minus 1. So option B. Clear? Sounds all right? Number 4. There is a parabola y squared equal to 16 into x minus k. And there is another parabola x squared equal to 16 into y minus L. This is another parabola. Y squared is 16 into x minus k. Another parabola, x squared equal to 16 into y minus L. These are two parabolas. K and L are variable parameters. So these would be variable parabolas. If K and L are variable entities, then these would be variable parabolas. Now, and however, they are not wildly variable. They vary in a manner that the two parabolas touch each other, always touch each other, right? Now, which means at the point where they intersect, they have a common tangent. If two parabolas touch each other, what does it mean? If this is, one of them is a parabola whose axis is parallel to the y-axis, the other one is a parabola whose axis is parallel to the x-axis. L and K are such that the two parabolas touch each other at a point P, x comma y. This point P will move. As the parabolas change, this point P, x comma y will move. There is a locus associated with this xy. Now, this is the point of contact. Therefore, this is the point of contact at the two parabolas, and this will also be the common tangent. We now want to find out the locus of P. Locus of P. That means dy dx for this parabola at x comma y must be equal to dy dx of this parabola at x comma y. Because dy dx at any xy represents what? Slope of the tangent at xy. So find the dy dx of this parabola at x comma y. Find the dy dx of this parabola at x comma y. And equate the two dy dx's. Because both the dy dx's will represent the slope of their common tangents. Yes or no? Right? Okay. Now from this equation, 2y dy dx is 16. Yes or no? From this equation, 2x, differentiating with respect to x, 2x is 16 dy dx. Yes or no? Now, this dy dx I can write as 8 by y. Right? The dy dx I can take from here and write as 8 by y and plug into this. Right? 8 by y. So that's 2x. So this point of contact xy will always satisfy this equation. Yes or no? This then will be the locus of the point of contact P. Clear? Right? Which means that xy must be 64. P moves such that x into y is 64. In chemistry, you have done PV equal to constant. Rectangular hyperbola. Xy equal to constant will be a rectangular hyperbola. Xy equal to constant. This is xy equal to constant, which will be a rectangular hyperbola, right? You've done that in chemistry. PV equal to constant. The graph of P into V equal to constant is a rectangular hyperbola. So xy equal to constant will be a rectangular hyperbola. So the locus is a hyperbola, more specifically a rectangular hyperbola. Yes or no? Right? Clear? Very simple. There is a parabola, there is a point P on the parabola, 8t1 squared comma 2at1. There is another point Q on the parabola, 8t2 squared comma 2at2. And this line will always pass through a point C. Oh, this is A and B. Okay, A and B. This will pass through a point C, 0 comma B. Which means the line passing through A and B must pass through 0 comma B. So I have like a y minus 2at1, or rather the slope of this line is what? In this case, y minus 2at1 by x minus at1 squared is slope of this line y2 minus y1 by x2 minus x1. That makes it 2 by t1 plus t2. isn't it? 281 minus 282 divided by 8t1 squared minus 8t2 squared would be 2 by t1 plus t2. Yes or no? And x equal to 0, y equal to b will satisfy this equation. So put x equal to 0 and y equal to b and be done with it. Yes or no? So you have y into t1 plus t2 minus 2at1 into t1 plus t2 equals 2 into x minus 8t1 squared. Minus 2at1 squared minus 2at1 squared would cancel from both sides. Do you see that? So you have y into t1 plus t2 minus 2at1 t2 is 2x. So put x equal to 0 and y equal to b. Put x equal to 0 and y equal to b in this case. So b into t1 plus t2 equal to 0 is the required condition. You didn't need to know parabolas for this. How does it matter? It'll still lie on this line, isn't it? It'll still lie on this line. It can be anywhere. Huh? वही तो. It didn't require parabolas for this. Yeah. It's hardly a problem. Now, let me mention a few little simple things. Can I wipe this off? All's good so far, right? See, and interpret this physically. First, I'll give you a result for a standard parabola, but interpret this physically. Very simple thing, actually. This is a parabola, say y square equal to 4ax. Standard parabola. The x-axis is the axis of symmetry. This is the y-axis, tangent at the vertex, 0, 0, focus S, A0. Right? There is a point P. Any point on this parabola is at squared, comma, 2at. Thank you so much. Right? It was getting noisier than I am. So now if I draw a normal at P, this is a normal at P, right? That means it's perpendicular to the tangent at P. Right? And it intersects the axis of symmetry, which so happens to be also the x-axis, right? In any case, it's the axis of symmetry at some g, right? Now, the equation, what's the slope of this normal? Minus t. Don't forget, keep forgetting this. Minus t is the slope of the normal. The slope of the tangent at t is 1 by t. Then the equation of the normal at P is y minus 2at is minus t into x plus at squared, x minus at squared. Right? That's the equation of the normal at P. Now to find the intersection with the axis of the parabola, put y equal to 0. So if you plug in y equal to 0, you get x is 2a plus at squared, which is greater than or equal to 2a always? Yes or no? Which is always greater than or equal to 2a, clear? Now, if this is 2a plus at squared, comma something, physically, what it means is See, this could be looked upon as a normal drawn from a point on the axis. You can look upon this as a normal drawn from the axis, right? This could be looked upon as a normal drawn from the axis of the parabola, right? G is at the point on the axis. Now, what it really means is, what is 2a plus 80 squared? Distance from the vertex? 2a plus 80 squared is actually distance from the vertex. Yes or no? Is the distance from the vertex. GV is the distance from the vertex. Imagine this to be the distance from the vertex. And this in turn, distance from the vertex in turn is always greater than or equal to 2a. 2a is what? Semi-latus rectum. 2a is semi-latus rectum. Semi-latus rectum, SLR, L, small, semi-latus rectum, right? Yes or no? Now, that means, if this is A units, this is A units obviously, this must be greater than A units, this must be greater than A units, yes or no, right? Which means, from a point on the axis, if someone says, how many normals can be drawn? If this is greater than or equal to A, then there are 3 normals that could be drawn to the parabola. At t, at minus t, and one would be perpendicular to the tangent at the vertex. From the axis of the parabola, 3 normals could be drawn in a very general sense. In a very general sense, 3 normals could be drawn to the parabola, right? One, which is the axis itself, which is perpendicular to the tangent at the vertex. That's always the case. The other 2 normals would be, one would be a normal at t, the other one would be a normal at minus t. Because the normal at minus t will also intersect the parabola is at 2a plus a into minus t squared, yes or no? So both the normals at t and minus t would intersect the axis at 2a plus 80 squared, yes or no? Right? Now, having said this, if this distance is greater than or equal to a, if this distance is greater than or equal to a, which it should be, right? Then there are 3 real normals could be drawn to the parabola. That means, if, say this is the vertex, this is the focus, and so this point is some point P, which is 2a comma 0, which is some point, this is a units, this is a units, right? Which means, think of it like this. Any real normal would intersect the axis to the right of P. Any real normal drawn to the parabola anywhere would intersect the axis to the right of P, because 2a plus 80 squared, so to the right of P. That means more than a units from the focus on the axis, more than a units from the focus along the axis, which means there would be no real normal that would intersect the axis to the left of P, right? There would be no real normal that would intersect the axis to the left of P. Now, if you choose a point to the left of P, any point to the left of P, then one normal will always be the axis itself, but that will be the only normal, because no other normal will pass through a point to the left of P on the axis of the parabola. Yes or no? You know what I'm saying? So if a point is chosen to the left of P, left of 2a comma 0, that means this is a units, this is a units. Imagine this physically. This is a units, this is a units, right? S must be the midpoint between the vertex and P. S must be the midpoint between the vertex and the point P, physically. Then any point P chosen to the left of P will result in only one real normal drawn to the parabola, right? But any point chosen to the right of P will result in 3 real normals. One would be at t, the other one would be at minus t, and the third one would be along the axis itself. You know what I'm saying? So if you are seeking 3 near real normals to the parabola from a point on the axis, if you are seeking 3 real normals, that means you select a point M, which is h comma 0. If you are seeking 3 real normals from this point, then h must be greater than or equal to 2a. H must be greater than or equal to 2a. Only then 3 real normals could be drawn to the parabola, right? But if you choose any point on the axis to the left of P, see, if I select this point, there will be 3 real normals. One would be normal at a point T, the other one would be a normal at the point minus T, and the third one would be the axis itself, which is perpendicular to the tangent at the vertex. 3 real normals if you are choosing H, 0 to the right of P. But if you are choosing a point to the left of P, then only one real normal could be drawn, which is the axis itself. The other 2 normals are imaginary normals. Yes or no? Do you understand this fact very clearly? Physicality? Physicality, you understand? That means if this is A units, 1/4 the latest rectum, then this will also be 1/4 the latest rectum physically, right? Any point on the axis beyond this point will result in 3 real normals. Any point to the left of P will result in only 1 real normal. Have you mentally acclimatized to this thought? Now, let's look at the problem. Sorry?
The normal drawn just above the vertex on the parabola will meet the axis of symmetry.
Almost. Very, very far away. You're right. Very far away. Absolutely. Very well said. Refer to problem number 6. There is a parabola y squared equal to 4x plus 8. Right? Which is 4 into x plus 2. 4 into x plus 2. Let us trace this parabola. This parabola has axis of symmetry, y squared equal to 0. That means the x-axis is the axis of symmetry, right? For this parabola, x-axis is the axis of symmetry. The vertex of this parabola will be what? Minus 2 comma 0. The focus of this parabola will lie somewhere here along the axis. A is 1 unit. 4a is 4, so a is 1 unit. So 1 unit along the axis. So that's going to be 1 unit from here, which would be minus 1 comma 0 is the right. And that threshold point P, if this is 1 unit, another 1 unit, which is 0 0, right? P is such that S must be the midpoint between P and the vertex, which means now, I hope all of you understand this. This is 1 unit. This is like 2A. This is like 2A, isn't it? 1 and 1, 2A, right? So which means now, if you want real normals to the parabola, then you must select points only to the right of P. Yes or no? That means, if M is a point whose coordinates are k comma 0, then k must be greater than or equal to 0, because M must be a point to the right of P. So k must be greater than or equal to 0 if you want 3 real normals to the parabola. Yes or no? Sounds good? Okay. Let's look at number 7. Let's look. Okay, now. No. Let me tell you another thing. I'm going to discuss that also. That's a good question to ask. There is a reason I have not discussed that. This is the line x equal to 2a. This is the line x equal to 2a. In fact, let me tell you that even if you selected any point M prime to the left of P anywhere, there would be only one real normal that you could draw to the parabola. For real normals, if you selected a point M prime to the right of P anywhere, then one real normal is always guaranteed, but the other two normals may or may not be real. But if you selected a point m prime to the left of this line x equal to 2a, you can be sure that there will be only one real normal. I'm going to discuss that also. So for sure, one thing, if there is a point h comma k, m prime h comma k, and if you select h less than 2a, if you select h, right, this point is h comma 2a, h comma k, h less than 2a, then there is only one real normal. H greater than or equal to 2a may mean one real normal or all three real normals. One real normal or all three real normals. That is possible. But h less than 2a will certainly mean only one real normal. That's for sure. Right? I mean, this k is different from this k, so not to confuse you, call it k prime, because this k is for the problem, right? From all points in the plane, there are only two possibilities. Either only one real normal or all three real normals. You can't have two real normals and one imaginary normal. Reason being, see, a polynomial of degree n whose coefficients are real numbers. Let me just tell you this. A polynomial of degree n whose coefficients are all real numbers, right? Say if there is a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus an, where a naught, a1, etc. are all real numbers. Now, if there is if this has a complex root 5 plus 2i, then it will have also a complex root 5 minus 2i. Complex roots will always occur in pairs. Complex roots of a polynomial whose coefficients are real numbers will always occur in pairs. We can establish that fact. We'll do that, right? Which means the number of complex roots of a polynomial with real coefficients must be even in number. A polynomial can have either 0 complex roots, or 2 complex roots, or 4 complex roots, or 6 complex roots, even number of complex roots. It can't have an odd number of complex roots if the coefficients are real numbers, right? So now the three normals drawn from hk, at cube plus t into 2a minus h minus k equal to 0 will give me the t's of the three normals drawn from hk. This is a polynomial of an odd degree. This is a polynomial of an odd degree, right? Now, can it have all three real roots complex? Or sorry, all three roots complex? No, because complex roots will always be even in numbers. So this can have either 0 complex roots and 3 real roots, or 1 complex root and 2 real roots. 2 complex roots or 1 real root. 2 complex roots or 1 real root, or 3 roots real. All 3 roots real, or 2 complex roots and 1 real root. So this will have either all 3 normals real, either all 3 normals will be real, or there would be 1 real normal and 2 imaginary normals. That's the only possibility. So 1 real normal is always guaranteed from any point. 1 real normal is always guaranteed from any point. You know what I'm saying? Yes. Suppose, no, there is a condition. If AIs are not just real, but also rational numbers, if these AIs are rational numbers, then irrational roots will always occur in pairs. That means if 2 plus root 3 is an irrational root of the polynomial, then 2 minus root 3 will always be a root as well. So not only do complex roots occur in pairs, complex roots occur in pairs if the coefficients are real numbers. Irrational roots occur in pairs if the coefficients are not only real numbers but are also rational numbers. Now number 7. there is a parabola y squared equal to 1 by 16 into x is a parabola given to you. And there is a normal chord at the point T of the parabola, and it subtends a right angle at the vertex. It subtends a right angle at the vertex. That means this parabola, what is its vertex? Its axis is the x-axis. Its vertex is 0, 0. Right? Yes or no? In this case, 4a is 1 by 16. Right? Now, at a point P, which is some t equal to t1, say t equal to t1, a normal is drawn. That normal has the other end t equal to t2. Right? P has coordinates a t1 squared comma 2a t1. Q has coordinates a t2 squared comma 2a t2, the coordinates of Q. Right? And it's given that this is 90 degrees. This is 90 degrees. It's given. Right? So 2a t1 minus 0 by a t1 squared minus 0. That's a slope of PV into slope of QV, 2a t2 by a t2 squared minus 0. That must be equal to minus 1. Right? So that gives me t1 t2 equal to minus 4. t1 t2 equal to minus 4, yes or no? Right? I hope all of you understand this. t1 t2, see, 1 t1 t2 will get cancelled, a will get cancelled, and minus, so t1 t2 equal to minus 4. Right? Now we want to find the value of t1. We want to find the value of t1. t2 is the other end of the normal at t1. So t2 would be minus t1 minus 2 by t1. Did I discuss this yesterday? The t of the other end of the normal would be minus t1 minus 2 by t1. So this t2 I want to solve for t1. So t2 I can write as minus t1 minus 2 by t1. Equal to minus 4. Right? Which gives me t1 squared plus 2 equal to 4. t1 squared is 2, or t1 can be plus minus root 2. So the two values of t are plus root 2 and minus root 2. Of course, one of them is given, option A, which is minus root 2 is given. Very clearly, whatever you can do from t equal to plus root 2, you can do from its mirror image t equal to minus root 2 is its mirror image. Right? It enjoys symmetry about the axis. T equal to plus root 2 and t equal to minus root 2 are mirror images of each other about the axis. Yes or no? So whatever can be done with t equal to root 2 can also be done with t equal to minus root 2. So option A, minus root 2 is the legal option here. Right? See, in number 8, there are two lines given. One line is y minus b is m1 into x minus a. The other line given is y minus b is m2 into x plus a. And there is a parabola y squared equal to 4ax. X plus a, right? Y squared equal to 4ax. That means this parabola, x-axis is the axis of symmetry, vertex 0, 0, focus a 0, and directrix x equal to minus a. Yes or no? Right? Now, the two lines intersect at a point. Do you see from inspection that the two lines have intersect at minus a comma b? Do you see both lines intersect at minus a comma b? right? Both pass through the same point, which is a point on the directrix. Which is a point on the directrix, yes or no? Minus a comma b is a point on the directrix. So if it's a point on the directrix, then the two tangents drawn from the directrix to the parabola would be perpendicular to each other. That means these two lines must be perpendicular to each other, and therefore the product of their slopes must be minus 1. M1, M2 must be minus 1. Right? Number 9. There is a parabola y squared minus 4x minus 2y minus 3 equal to 0. And there is a point P given, which is minus 2 comma 1. We want to figure out the number of distinct normals, means real normals that could be drawn to the parabola from this point, right? So let's first draw the parabola. This is like y minus 1 whole squared, so plus 1 minus 1 4, so that's 4 into x plus 1. That's this parabola. Axis of symmetry is y equal to 1. Is the axis of symmetry. Minus 1 comma 1 is the vertex. Minus 1 comma 1 is the vertex. X has to be greater than or equal to minus 1 for this to be non-negative. A in this case is 1, 4a, A is 1. So 1 unit away from this will be the focus. So 0 comma 1 is the focus, right? Yes or no? Now where is this point? And that threshold point P would be 1 unit away from this. That means 1 comma 1 is the threshold point. From points to the right of P on the axis, 3 real normals could be drawn. But for any point to the left of P on the axis, only 1 real normal could be drawn. Where is the point minus 2 comma 1? Minus 2 comma 1, let's say P prime is a point here, minus 2 comma 1. So for any point on the axis to the left of P, only 1 real normal, which is the axis itself, that could be drawn to the parabola. So the number of distinct real normals is 1. Yes or no? Clear? So there is a circle S, which is x squared plus y squared minus 2a squared equal to 0 is the circle, right? Clear? Now, point AA. Do you realize AA is a point on the circle? AA is a point on the circle. Now, what is it that we are trying to do? From a point AA on the circle, we want to be able to draw two chords, two ABs. We want to be able to draw two ABs whose midpoint lies on the parabola. Whose midpoint lies on the parabola, right? AB should be bisected by the parabola. That means midpoint of AB must lie on the parabola. That means the midpoint must be of the form 80 squared plus 280 comma 280 will be a point on the parabola, right? How many such ABs are possible? We want to find. So the number of real values of T will give me the number of required ABs. The number of real values of T will give me the required number of ABs, right? Now, I hope all of you understand this. Huh? Understand the problem at least? Okay. Now, given the midpoint of a chord, equation of the chord in terms of its midpoint is going to be T equal to S1 in circle or parabola, where T in this case is xx1 plus yy1, etc. Right? Where x1, y1 is this. x1, y1 is this. T equal to S1 will give me the equation of the chord in terms of its midpoint. So, equation of AB in terms of M is T equal to S1. T means x, x1 y1 minus 2a squared is t, isn't it? X1 plus y1 minus 2a squared is t, equal to s1. S1 is what? X1 squared, which is x1 is 80 squared whole squared plus y squared, which is 280 whole squared minus 2a squared. Right? Now 2a squared will get cancelled. The number of values of t will give me the required number of such ABs, number of chords, right? One value of t, of course, is t equal to 0, as you can see. One value of t obtained from C, you can take t common and figure out that there is one value of t for sure, right? T equal to 0 will give me at least one AB. One such AB. Let's see if there are more. Let's see if there are more, right? Now, let me cancel the t's and the a's. So xt plus 2y, right? 1a will get cancelled and 1t will get cancelled from here, 1t will get cancelled from here. So xt plus 2y equals 80 squared. So 1a will get cancelled. So a, there is t cubed, right? Another a would get cancelled. So plus 4a t, 480, this is what it is, right? Now, this chord passes through a comma a. This chord passes through a comma a. So a comma a must satisfy this equation. So put x equal to a, y equal to a. Let me figure out the number of real roots of this, right? Another a will get cancelled, right? We end up getting t cubed plus 3t minus 2 equal to 0. T cubed plus 3t minus t equal to 0. Right? Now I have to figure out the number of real roots of this cubic. Number of real roots of this cubic. Let me call this ft. One real root it will certainly have. One real root it will certainly have. Let me see how many more, right? ft is what? T cube plus 3t minus 2. Let me look at the derivative function, f dash t. F dash, bless you, t is 3 into t squared plus 1, which is a quadratic in t. What is the discriminant of this quadratic? B is 0, minus 4, minus 3, which is less than 0. Right? So this cubic will have only one real root. If the discriminant of that quadratic is less than 0, then this cubic will have exactly one real root. Yes or no? Or ft equal to 0 has only one real root. So one is t equal to 0, another real root. This will have only one real root. Got me? Sounds good? So in all two, one is t equal to 0, the other one is 1t obtained from this, right? One is for t equal to 0, which we obtained earlier. That was one real value of t. And the other real root will be obtained from this.
If we take that 80 and 280 as h comma k, then won't it be a quadratic? So we'll get two values.
Huh?
So if we take that 80 square and 280 as h comma k, so it will become a quadratic.
Quadratic in what?
Sir, in h and k.
H and k. So you have to eliminate one, so it will become a cubic in one of them, isn't it? H and k में से you will have to eliminate one, na? So it will become a cubic in the other one, isn't it? Subjective problems.
Sir, one small thing.
Uh-huh.
Sir, in last problem you cancelled out 1t,
So that is t equal to 0, isn't it? That was t equal to 0 when I cancel. So I said that is 1. Now if that is not the other one, the remaining will be obtained by cancelling t. That's why I claimed first that t equal to 0 is 1. So in subjective problems, let's say the 11th problem of the sheet and the first of the subjective, there is a quadratic in x, y equal to ax squared plus bx plus c. What would this be? A parabola whose axis is parallel to the y-axis, right? This meets, so this is the parabola. There is a line that passes through the focus and meets the parabola at P and Q. And if SP is 4, SQ is 6, we want to find the latest rectum of the parabola. Remember the property I discussed yesterday? The semi-latest rectum would be the harmonic mean of the segments of any focal chord, right? So the semi-latest rectum, SLR, semi-latest rectum would be 2 divided by 1 by SP plus 1 by SQ. SP is known, SQ is known, semi-latest rectum would be known. Latest rectum then would be twice L. Latest rectum then would be twice L. Did I discuss this property earlier? Clear? Now, this equation x minus 1 whole squared plus y minus 2 whole squared equals lambda into x plus y minus 3 whole squared. Now it's known to represent a parabola. It's known to represent a parabola. Now different lambdas will give me different states, but we are seeking the value of lambda so that it can represent a parabola. Now this I could have written as x plus y minus 3 divided by 1 squared plus 1 squared root 2 whole squared into 2 lambda is x minus 1 whole squared plus y minus 2 whole squared. Now that means any point on the conic is such that its distance from the point 1, 2, there is a point 1, 2 and there is a line x plus y minus 3 equal to 0. Then this point xy is such that this is sp squared, and this is what? This must be pm squared. That means 2 lambda must be 1, so that this will be pm squared. This must be 1. Yes or no? So that sp squared is pm squared. So 2 lambda has to be 1. So lambda must be half. In order that sp squared is pm squared. In order that this is equal to this. For this to represent a parabola, sp squared is pm squared. This then would be the directrix. This would be the focus. This is square of the distance from the focus. And this must be equal to square of the distance from the directrix. And this 2 lambda therefore must be 1. Lambda therefore must be half. Got me? Number 13. So given the latest rectum AB, this is the latest rectum AB, how many parabolas are possible? 2, very clearly, because the perpendicular bisector of the latest rectum must be the axis, so the axis is known, right? Now if this length is x, this is x, then realize that the vertex could have been here, right? This must be the focus. The vertex could have been here. 1/4 the latest rectum. This must be 1/4 x by 2, or could have been here. These are 2 possible locations for the vertex if this be the latest rectum. That means the parabola could have either been like this or could have been its mirror image about the latest rectum. 2 possible parabolas, very clearly. Because given the latest rectum, there are 2 possible locations of the vertex. Axis is unique. The focus would be the midpoint of the latest rectum. That's unique. And The vertex could have been here or could have been there. So two possible parabolas out of this. Tangents are drawn to a parabola from a point on the directrix. This is a parabola. This is the directrix. Tangents are drawn from different points on the directrix. P, this is the directrix of the parabola, and we select different P's on the directrix and draw pairs of tangents, right? Now, these are points of tangency. These are points of tangency. This is the normal at A. This is the normal at B. The normals at A and B intersect at M. The normals at A and B intersect at M. So if I select different P's, there would be different M's. I need to find the locus of M. I need to find the locus of these M's. Yes or no? That's what we're seeking to do here. What will be a square? No, 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 no. It's a cyclic quadrilateral, all right, but it is not a square. PA is not PB. Circle nahi hai. It's not a circle. PA is not PB. PA is not PB. Right? What we need to do is we need to find the locus of this M. Need to find the locus of this M. Yes or no? Now, this M is say let's say the parabola is y squared equal to 4ax is the parabola. Let's say y squared equal to 4ax is the parabola, right? And M is h comma k. I need to connect h and k. I need to connect h and k without involving a parameter and then generalize. Replace h by x and k by y to get the locus of M. That's what I need to do. And say this A is foot of one of the normals from M to the parabola. B, which is T2, is the foot of the other normal drawn from M to the parabola. Yes or no? Do you also realize that AB must be a focal chord? Did I tell you? AB must be a focal chord, the chord of contact. Then must be a focal chord if P lies on the directrix. Right? That means for sure T1, T2 must be minus 1. T1, T2 must be minus 1. Now, realize that the three normals drawn from HK to the parabola would be given by AT cubed plus T into 2A minus H minus K equal to 0. Will be the three normals drawn to the parabola from HK. One would be at T equal to T1. One of the roots of this will be T1. The other one would be T2, and say there is going to be a third normal which would be at T equal to T3, which would be at T equal to T3. So T1, T2, T3 are roots, of which T1 and T2 are A and B respectively. Yes or no? Now, if T1, T2, T3 are the roots, then do you realize T1 into T2 into T3, product of the roots, is K by A minus 1 cubed into minus K by A, right? Yes or no? But AB is a focal chord because P lies on the directrix. So T1, T2 must be minus 1. Yes or no? That gives me T3 equal to minus K by A. Yes or no? T3 must be minus K by A. Hey, but T3 is a root of this, so it must satisfy this equation. T3 is a root of this, it must satisfy this equation. Clear? So if T3 is a root of 1, T3 equal to minus K by A is a root of 1, means A into minus K by A whole cubed plus T, which is minus K by A into 2A minus H minus k will be 0. In a general sense, k is not 0 always, right? So I can divide by k. K is not 0, so I can divide by k. So you will have a k squared and you will have an h. You can replace h by x and k by y squared. So x will be a quadratic in y, which will give you a parabola when you simplify. Yes or no? You'll eventually have a k squared here and you'll have an h here. So h and k squared will appear when you divide by k. So x will be a quadratic in y, which will give you a parabola when you simplify. Yes or no? So the locus of M given by the moving point hk will have h, a quadratic in k, leading to a parabola. Yes or no? Clear? You need to simplify. You can do that. You have a question. It's not always 0. K is not a specific number, right? It's a moving point. So you can divide by k. So there is one point. That's only one point. Isn't it? Let's look at 15. I can leave the simplification to you. You could also, you want to try slope. Also you can try PBMA is a cyclic quadrilateral. You can do that also. No, it will not be a rectangle. It will not be a rectangle, my friend. Under no circumstances. You mean to say for any P, PA will be equal to PB. Then PA will be equal to MB. No. Kite hoga. Right, it will be a kite. Kite on flight. That's all right. But not a rectangle. Not a rectangle. For sure not a rectangle. And actually, it's a rectangle only. It's a rectangle only. It's a rectangle. I stand corrected. Yes, it's a rectangle. It's a rectangle. It's a rectangle. 90 degrees, 90 degrees. This is 90 degrees. The normals are perpendicular and this is also. Yes, it's a rectangle. I stand corrected. You're right. No, it's a rectangle for sure. No doubt about it. It's a rectangle.
We can diagrammatically also say that it's a parabola because for everybody it will trace that parabola inside. So
Matlab how? No, it's a rectangle, all right. To that extent, I stand corrected. You're right. It's a rectangle because all angles are 90 degrees. There cannot be anything else. It is a rectangle, but three normals from a point P to the parabola. Say the problem number 15. Three normals from a point P to the parabola meet its axis whose coordinates are in AP. Find the locus of the moving point. Say the moving point is h comma k. The moving point is h comma k and the feet of the three normals drawn from hk to the parabola will be given by at cubed roots of this plus t into 2a minus h minus k is 0. Will give me the feet of the normals drawn from hk to the parabola. T1, T2, T3 are the feet of the three normals. The normal at T1 would intersect the axis at 2a plus a T1 squared. Would the x-axis at 2a plus a T1 squared. T2 would intersect the axis at 2a plus a T2 squared. And T3 would be 2a plus a T3 squared. These are the x coordinates of the point with the x-axis, with the axis of the parabola. Yes or no? I have discussed this, right? And they are in AP. These numbers are in AP. That's given. I want to find the locus of H, comma K, locus of P, such that these are in AP. Clear? Now, for these to be in AP, A T1 squared, A T2 squared, A T3 squared must be in AP. That means T1 squared, T2 squared, T3 squared must also be in AP. They must also be in AP, right? Now, if they are in AP, that means T1, T2, T3, the roots of this would be 2T2 squared is T1 squared plus T3 squared. Two T2 squared is T1 squared plus T3 squared, right? Now, using this condition, I need to eliminate H and K, I need to eliminate T1, T2, T3, connect H and K and generalize. Replace H by X and K by Y to get the locus of P. Right? Now, T1, T2, T3 are also co-normal points. So T1 plus T2 plus T3 must be 0. Yes or no? They are the roots of this. T1 plus T2 plus T3 must be 0. Right? Now this I can write as T1 plus T3 whole squared minus twice T1 T3. Right? T1 plus T3 whole squared minus twice T1 T3. T1 plus T3 is minus T2. So this is T2 squared minus twice T1 T3. Right? T1 plus T2 plus T3 is 0. So T1 plus T3 must be minus T2. So this will become T2 squared. The left hand side is 2T2 squared. So this gives us T2 squared is minus 2 T1 T3. T2 squared is minus 2 T1 T3. Yes or no? Now, look at the product of the roots. T1, T2, T3 is K by A. But T1 into T3 is minus T2 squared by 2. Minus T2 squared by 2. Isn't it? T1 into T3 is minus T2 squared by 2. Clear? Clear? There is a T2, so T2 cubed is what this will become. T1 into T3 replaced. So that gives me T2 cubed is minus 2K by A. T2 cubed is minus 2K by A. Clear? Hey, but T2 must be a root of this. Isn't it? So this T2 cubed plus T2 into 2A minus H minus K is 0. Plug in T2 as minus 2. So T2 cube would be minus 2K by A. T2 would be minus 2K by A cube root of this minus K, etc. Right? So A T2 cube is minus 2K. Right? Minus K. So that makes it minus 3K. And then cube root of this. So plus minus 2K by A whole to power 1/3 into 2A minus H is 0. You realize what I did? A T2 cubed is minus 2K. This is minus 2K and this is minus K. That makes it minus 3K. Then this T2 is cube root of this. T2 is minus 2K by A to power 1/3 into 2A minus H. That's 0. So then you can transpose this on this side. This equal to 3K. Cube both sides, replace H by X and K by Y. Cube both sides, replace H by X and K by Y to get the required locus. Parabola. Is it a parabola? No, no, it's not going to be a standard curve. It's not going to be a standard curve. It's not going to be a standard curve. No, name is there for this curve. This is just the locus, right? Let's look at number 6. There is a circle of radius A. This is a circle of radius A. And a parabola is drawn to pass through the ends of the diameter of this circle. AB is a diameter of this circle of radius A, and a parabola is known to pass through these 2 points. And this is concentric with a circle of radius B. This is a circle of radius B. The parabola that is known to pass through A and B has its directrix, which is a tangent to this. Has its directrix, which is a tangent to this. Clear? This tangent to this circle is the directrix of the parabola. Now, the axis being AB. Now, this can be so this is my parameter, because there can be very many tangents to this. So, even though these 2 are fixed points through which the parabola passes, the parabola is not uniquely determined, right? Because the directrix can vary, because you can have very many tangents to the concentric circle. Clear? The axis of coordinates is, let's say this is the x-axis, and a line passing through the midpoint, that's the y-axis. See, that's the y-axis. Then the equation of the inner circle of radius A, this being the center, its center being the origin, is going to be x square plus y squared equal to a squared, right? Outer circle, that is this circle, the equation is going to be x square plus y squared equal to b squared. Inner circle a squared, that's b squared, right? Now, any tangent to a circle x squared plus y squared equal to b squared must be of the form y equal to mx plus b root 1 plus m squared. Remember this? Any tangent to the circle is y equal to mx. M is a parameter here. M is a parameter, right? Different m's will give me different directrices, and therefore different parabolas passing through A and B. Clear? Now, so if there are different parabolas, there are different foci. There are different foci, right? So there is a locus of the focus, right? We need to find the locus of the focus of these variable parabolas. Yes or no? That's objective. Do you understand the issue here? Okay. So suppose S is the variable focus whose coordinates are h comma k, whose coordinates are h comma k. Clear? All right. Coordinates of B would be a0, coordinates of A would be minus a0. Yes or no? Now, distance of B from S must be equal to distance of B from the directrix. That's a property. Distance of B from S must be the same as distance of B from the directrix. What is the distance of B? Because B is a point on the parabola, its distance from the focus must be equal to its distance from the directrix, right? So, distance of B from this is root h minus a whole square plus k squared. Now, this can be written as this minus y equal to 0 is the equation of the directrix, right? Equal to mod of distance of this line, directrix from a0. So that's going to be ma plus b root 1 plus m squared. Put x equal to 0, y equal to 0, x equal to a and y equal to 0. put x equal to a and y equal to 0 and divide by root coefficient of x whole squared plus coefficient of y whole squared. That means m squared plus 1. Yes or no? So far so good? Now, in this expression, see, origin and B lie on the same side of this line, let's say. Origin and B lie on the same side of this line. So, origin gives me a positive number. If you plug in x equal to 0, y equal to 0, this expression is rendered positive. So, if you plug in x equal to a and y equal to 0, then also this expression must be positive. That means the quantity inside the modulus must be a positive number. Because 0, 0 and a0 lie on the same side of the directrix, they must impart the same sign to this expression. X equal to 0, y equal to 0 is imparting this expression a positive sign. So x equal to a and y equal to 0, which is this expression, must also be positive. Yes or no? If it's positive, then modulus of a positive number is equal to the number itself. Right? So I can strip the modulus out. That's as far as B is concerned. The same equation will hold good for A. Just in this, replace A by minus A. In the same equation, replace A by minus A. You get the corresponding equation for A, because A is also a point on the parabola. Its distance from the focus must be equal to its distance from the directrix. So all that you need to do is replace A by minus A. So when you do that, then you get root h plus a whole squared plus k squared is minus ma plus b root 1 plus m squared divided by root m squared plus 1. Yes or no? These are two equations. What's the parameter? M is the parameter. What is it that I need to do? I need to connect h and k and generalize by eliminating m, the parameter. Now I have only an algebraic disposition. The geometry is over. The algebra begins. This is all that I have. Can I remove the clutter from here and work through the algebra? So one thing, yes, if you add, m doesn't get eliminated completely. So if I add, what do I get? MA will get cancelled. So that will give me 2B or not to be. I can simplify this. No, I will not do that. I can simplify this by squaring this. Then I'll have to square one more time because it'll be dirty, filthy, ugly. I don't want to get into that mess. Right? Let's be a little smarter in simplifying this. Okay. This we understand. I've eliminated m. Now the process of simplification begins. That's all right, but I have not taught ellipse here. Right? You're right in a certain sense, but I have not taught ellipse, so I'll get into algebra only right now. Right? Tell me this. Is it 4AH? This minus this. Yes or no? Is it 4AH? A minus B by root A plus root B will give me root A minus root B. See, this is A minus B divided by root A plus root B will give me root A minus root B. Yes or no? When I divide this by this, let me call it 3, let me call this 4. 3 is obtained by adding 1 and 2. Yes or no? You know what I'm saying? So if I divide this by this, this is capital A minus capital B divided by root A plus root B. I get root A minus root B. Right? So when I divide 4 by 3, when I divide 4 by 3, What do I get? Root h plus a whole squared plus k squared minus root h minus a whole squared plus k squared, which is 2ah by b. Yes or no? No, I'll add 3 and 5. I'll add 3 and 5. Let me add 3 and 5 now. Right, now when I add 3 plus 5, I get 2 root h plus a whole squared plus k squared is 2 into ah by b plus b. Yes or no? Right? Now, of course, if I square, this goes into oblivion. This is what happens. And now, h squared into 1 minus a square by b squared plus k squared equal to this a squared I transpose on the other side is b squared minus a squared. Now I divide by b squared minus a squared both sides. So h squared by b squared minus a squared. I'm sorry. It'll be b squared plus k squared by b squared minus a squared equal to 1. Generalize. Replace h by x and k by y to get the locus of the focus. X squared by b squared equal to 1. Hocus pocus mumbo jumbo. All's good?